Come on, my dears, let us proceed further in chapter number 8. Before we go ahead in the theoretical part, I would like to discuss about one very important extra question based upon some points of differences between progressive waves and stationary waves. It's very important question, just prepare it, okay? Look. Here I am writing for progressive waves. What was the another name for progressive waves? It was travelling waves, correct? I have written in bracket travelling waves. On right hand side, come on, stationary waves. Another name was standing waves, correct? Come on. What is called progressive wave? A wave which propagates ahead and ahead continuously in the medium is called progressive wave, correct? Fine. So that's what I have written here. Such waves propagate ahead and ahead. And here, such waves remain in the finite region of the medium, correct? If you are talking about stationary waves produced in the string, then we know from both the ends which were tied with the fixed rigid supports, the waves were getting reflected often and often. So here waves are no doubt produced, but they are produced within the finite region of the medium. They do not propagate ahead and ahead. Okay, fine. Then second point, energy is propagated by such waves. You know, during the propagation of travelling or progressive wave, energy is given gradually, subsequently, consecutively to the particles coming in the way along the direction of propagation of wave. So there the energy is propagated from one place to another place, correct? Propagation of energy is possible in case of progressive wave. But here in case of standing waves, we know whatever energy we have given to the medium just to make it oscillating, that energy remains in the medium itself, okay? That energy does not propagate. That energy remains within the same dimension of the medium, correct? That's what I am writing here. Energy is not propagated by such waves, okay? Stationary waves cannot propagate the energy, fine. Here amplitudes of all particles are same. If you neglect the internal resistance of the medium, then during the propagation of progressive wave, amplitude of oscillation of each particle is found to be same. And here, last time remembered we had derived the expression for amplitude of stationary wave. What was that formula? A dash equals to 2a sin kx. A dash equals to 2a sin kx. I mean to say, for different particles of the medium, the positions are different. Depending upon that, x value will change, and depending upon that, amplitude will change. So I mean to say, for all the particles in case of stationary waves, amplitudes are not same. Here amplitudes are same, here amplitudes are not same, okay? The amplitude of a given particle would depend on its position. As position will change, definitely the amplitude will change, okay? Then here frequency and wavelength can change continuously. With what frequency do you want to produce the wave? That is what you have to decide, correct? You can vary that frequency continuously. Depending upon that, the wavelength value will also change continuously. So here frequency and wavelength may vary continuously. But here, remember last time we had obtained two formula. One was the formula for frequency, and that was Fn equals to n into V upon 2L. Fn equals to n into V upon 2L, and another formula was for wavelength. It was lambda n equals to 2L upon n. Lambda n equals to 2L upon n, correct? And at that time, values of n we were changing specifically, 1, then 2, then 3, dash, dash, dash. As you change the values of n specifically, naturally frequency and wavelength will also change specifically. And I told you last time about the concept of quantization. Whenever any physical quantity assumes certain specific values, certain discrete values only, and not the remaining values, then that physical quantity is said to be quantized. So here also frequency and wavelength, they assume only certain specific values, not all the values, correct? That's why here in case of stationary waves, the values of frequency and wavelength are said to be quantized. That's what I am writing here. Frequency and wavelength are found to be quantized. Okay, fine. Then here wave pattern changes periodically. If you have propagation of wave on the water surface, then if you concentrate on the limited part of the water surface, then you will notice that that part during the upward displacement forms the crest, during the downward displacement it forms the trough. I mean to say same part is oscillating up and down. So whatever wave pattern do you observe, that wave pattern changes periodically. But in case of stationary waves, whatever wave pattern do you notice in the medium, that wave pattern for some time remains stationary, correct? So here wave pattern changes periodically, here wave pattern does not change. It seems to be stationary. It seems to be stationary. That's why that waves are called stationary waves. Fine. Then last point. There are no nodes or antinodes. In case of progression of progressive wave, in case of propagation of progressive wave, you know there are no nodes, there are no antinodes, correct? What do you mean by node? Node is that position in the medium where the particle should have zero amplitude constantly, and antinode is that position where the particle should have maximum amplitude continuously, correct? I mean to say there are no nodes, there are no antinodes in case of progressive wave. And here during the formation of stationary waves, last time we had seen there are certain positions where the particles had zero amplitude, they were called nodes, and there were certain positions where particles had maximum amplitude and they were called antinodes. So during the propagation of stationary waves, remember there are nodes, there are antinodes. Okay. So these many points you can just try to understand and remember. It may be asked in the examination. Okay. Differences between progressive waves and stationary waves. Got it? Fine. Now last time I just skipped one very small point. Let me mention right now. Normal modes of vibration. Last time we had considered an extremely thin string which is stretched and kept under proper tension and tied at both the ends with two fixed rigid support. And then when we had produced stationary waves in that string, we had noticed that possible values of frequency are given by this formula Fn equals to n into V upon 2L. And possible values of wavelength are given by this formula lambda n equals to 2L upon n. Okay. Now, such oscillations performed by the string in case of stationary waves, which are performed with definite frequency given by this formula, they are called normal modes of vibration. In short, if you want to define normal modes of vibration, it is very simple. Vibrations performed by any medium during the formation of stationary waves, which are given, which are having frequency given by the formula Fn equals to n into V upon 2L, are called, normal modes of vibration. I repeat, vibrations performed by a string, right now we consider string, okay? Vibrations performed by a string having frequency Fn equals to n into V upon 2L during the formation of stationary waves are called normal modes of vibration. Normal modes of vibration. Got it? Fine. Now read this statement of illustration number 13. Read it? Look. The length of the string they have given 60 centimeter. So capital L is length of the string, which is right now 60 centimeter. Wait. What is the equation of stationary wave they have given in the statement? Y equals to 4 sine pi x upon 15 cos 96 pi t, that many centimeter. The way they give the equation of a wave, accordingly, similarly, we should arrange the terms in the standard format. So standard format of equation of stationary wave, you should arrange this way. Here when they are giving with plus sign, here also you should write with plus sign. Normally what we write? Y equals to minus 2a sin kx cos omega t. Last time we had derived the expression of stationary wave, correct? Y equals to minus 2a sin kx cos of omega t. But here they have given with plus sign, then here also we should write with plus sign. Y equals to plus 2a sin kx cos omega t. Now tell me, if you compare these two, then 2a will be equal to 4. When 2a is equal to 4, what is a? It is 4 upon 2, that is 2 centimeters. Simple. So right now amplitude is how much? 2 centimeter. Mind well, this is not the amplitude of stationary wave. Amplitude of stationary wave is given by formula 2a sin kx. Please remember. This is the amplitude of one individual wave. Amplitude of one individual wave. Before superposition, whatever was the amplitude of individual wave, that amplitude is 2 centimeter. Correct? Fine. Now, come on, coefficient of x is k. Coefficient of x is right now pi upon 15. So, k equals to pi upon 15. K equals to pi upon 15. Correct? What is k? Wave vector. And what was the SI unit of wave vector? Last time we had seen radian upon meter. But right now you are taking this value of y in centimeter. That's why I am putting here radian upon centimeter. What about formula of k? Don't you know? It is 2 pi upon lambda. And right hand side as it is, pi 1s are pi getting cancelled. Find out lambda, it will be 15 to the 30 centimeter. Correct? Fine. What about coefficient of t? Here it is omega. Coefficient of t, here it is 96 pi. So omega must be equal to 96 pi. Omega must be equal to 96 pi. What is the unit of angular frequency? Radian per second. I am putting here radian per second. What do you mean by angular frequency? It is frequency multiplied by 2 pi radian. Frequency multiplied by 2 pi radian. And right hand side as it is, come on, pi 1s are pi getting cancelled. F will be 96 upon 2, that is 48, that many hertz. Okay. In this example, they have not asked the wave velocity, but they may ask. If they ask about wave velocity, don't you know the formula for wave velocity? V equals to F lambda. V equals to F lambda. F is this much, lambda is this much, just multiply. Okay. But take care regarding the unit. You are putting value of lambda in centimeter. So you must write the unit of wave velocity at that time, centimeter per second. Got it? Fine. Now they have asked the positions of nodes. Positions of nodes. From the theory, have you remembered? At which positions will we get nodes? At positions or at distances from one end of the string, at distances, come on, 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda, dash, dash, dash. At this many distances, we will get nodes. That much you must remember from theory. Now use that result here. Come on, positions of, distances of nodes from one end of the string. If I show by symbol xn, then you know the values 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda, dash, dash, dash. Same values are written here. Fine. Now this 0 as it is. What about lambda? Right now lambda is 30 centimeter. Put everywhere. Lambda equal to 30 centimeter. Put everywhere. 30 upon 2. That is 15 centimeter. This lambda is 30 centimeter. Lambda is 30. 33 is 90 upon 2. 45 centimeter. Put lambda equal to 30. 30 into 2. That is 60 centimeter and so on. In short, after starting from 0, you may go on adding 15 centimeter every time. You will get all these values. Correct? So at 0, 15 centimeter, 30 centimeter, 45 centimeter, 60 centimeter, dash, dash, dash. At these many distances from one end of the string, you will get nodes. Okay. Similarly, they have also asked the positions of antinodes. Positions of antinodes. From theory, have you remembered at which distances from one end of the string you are going to get antinodes? At how many distances? Lambda by 4, 3 lambda by 4, 5 lambda by 4 dash dash dash. Remembered? Come on. Lambda by 4, 3 lambda by 4, 5 lambda by 4 dash dash dash. Correct? These distances are different than this. That's why I am putting different symbol. Here xn and here xn dash. Okay. What about lambda? Lambda is right now 30 centimeter. Put it here. 30 upon 4. It will be 7.5 centimeter. Put here lambda equal to 30. 33 is 90 upon 4. 22.5 centimeter. And here when you write lambda equal to 30 centimeter, 35 is 150 upon 4 is 37.5 centimeter dash dash dash. In short, after starting from 7.5, every time you should go on adding 15 centimeter. Got it? Fine. So at this many distances from one end of the string, we will get antinodes. Okay. So we have determined the positions of nodes as well as antinodes. And now they have asked amplitude or maximum displacement for that particle which is at 5 centimeter from one end of the string. Don't you know amplitude of stationary wave? What is the formula? A dash equals to 2a sin kx. A dash equals to 2a sin kx. A dash equals to 2a sin kx. Correct? Wait. They have asked maximum displacement. But don't you know maximum displacement is nothing but amplitude? Fine. Now this 2a value altogether it is 4. So 2a value is 4 sin as it is. What about k, small k, wave vector? We have found out it is pi upon 15. K is pi upon 15 into x. What is the distance x given to you in the statement? 5 centimeter. So x is 5 centimeter. Now 5 3 is 15. And don't you know sin pi by 3 is nothing but root 3 by 2. So 4 into root 3 by 2 means it is 2 into root 3 that many centimeter. 2 into root 3 that many centimeter. Got it? Fine. Now they have asked the equations representing two component waves out of which this stationary wave is produced. So we are looking for equations representing component waves. Okay? Come on. The same equation are written here. Same equation. Correct? But instead of 4, I am just writing 2 into 2. Will do? No problem. Instead of 4, I am putting 2 into 2. That's all. And now there is a formula in trigonometry. 2 sin alpha cos beta. 2 sin alpha cos beta. You can always write sin of alpha plus beta plus sin of alpha minus beta. Here it is. Sin of alpha plus beta plus sin of alpha minus beta. Okay. Utilize this result over here. 2 sin alpha cos beta. Look here. 2 sin, take this as alpha, cos, take this as beta. So now it will appear like 2 sin alpha cos beta. 2 sin alpha cos beta. You can rewrite as sin of alpha plus beta plus sin of alpha minus beta. Come on, these two as it is. Correct? And now 2 sin alpha cos beta. In place of that, what we will write? Sin of alpha plus beta plus sin of alpha minus beta. Here it is. Sin of alpha plus beta plus sin of alpha minus beta. Correct? Alpha means here pi x upon 15 and beta means 96 pi t. Alpha means pi x upon 15, beta means 96 pi t. Here it is alpha plus beta and here it is alpha minus beta. Got it? Fine. Now just multiply by 2 inside. Multiply by 2 inside. So it is now 2 sin pi x upon 15 plus 96 pi t as it is plus 2 sin of pi x upon 15 minus 96 pi t. Got it? Now tell me. Take this first term as y1. Take this second term on right hand side as y2. So now this equation will appear like y equals to y1 plus y2. Y equals to y1 plus y2. Where y1 and y2 are respectively this term and this term. They will represent the component waves. Come on. y1 equals to 2 sin pi x upon 15 plus 96 pi t. That many centimeter. and y2 equals to 2 sin pi x upon 15 minus 96 pi t, that many centimeter. So these two equations represent two component waves, and when they superpose on each other, they will produce stationary wave given by this equation. Got it? Come on, this is the equation representing stationary wave, and these two are the equations representing two component waves. Got it? Fine. Kindly read the statement of number 14. Have you read it? Look. I for incident. This equation they have given, which represents incident wave. Yi equals to capital A into cos of Ax plus Bt. Capital A, small b, they are constants. Fine. Now, the way they give the equation of wave, similarly we should arrange the standard format. Yi equals to A, if they are giving cos, then you also should write cos. You know coefficient of x, we write as small k, that is wave vector. Coefficient of t, we will write omega, angular frequency. So come on, here they are giving plus, then here also we should write plus. Here plus, then here plus. Suppose here it is minus, then you may write here minus. Okay. Here sine, then you can write here sine. Here cos, then here you should write cos. Got it? Fine. Now just compare these two. When you compare, coefficient of x is k, here coefficient of x is a, so k equals to a, k equals to a. But don't you know k? What is k wave vector? It is 2 pi upon lambda, 2 pi upon lambda. Find out lambda, take this a in the denominator, lambda will be 2 pi upon a, lambda will be 2 pi upon a. Come on, coefficient of t is omega, coefficient of t is b. So when you compare, omega equals to b, omega equals to b. But don't you know angular frequency? What is it? Frequency multiplied by 2 pi radian. Come on, omega is frequency multiplied by 2 pi radian. Find out f from here. It will be b upon 2 pi. F equals to b upon 2 pi. They have asked in the first section, they have asked the formula for frequency and wavelength. That is what we have derived in terms of A and B. Got it? Fine. While teaching you the definition of intensity of wave, I told you one result which you must remember. Come on, intensity of any sort of wave is definitely directly proportional to square of its amplitude. I proportional to a square. Remember, now onwards, I proportional to a square. Intensity of a wave is directly proportional to square of its amplitude. Now, if you utilize this result for incident and reflected wave, you may write this way mathematically. Come on, take the ratio on left hand side. It will be IR upon II, that is intensity of reflected wave divided by intensity of incident wave, and that should be equal to the ratio of squares of respective amplitudes. Come on, AR square upon AI square. Here R, here I, then here also R and I. Okay, just take care regarding the order. Okay, IR upon II will be equal to AR square upon AI square. What do you mean by AR? Amplitude of reflected wave. What do you mean by AI? Amplitude of incident wave. Correct? Now they have given in the statement that intensity of reflected wave is 0.64 times intensity of incident wave. That is what they have given in the statement. Look, intensity of reflected wave is 0.64 times intensity of incident wave. Then why don't you find out IR upon II from here only? IR upon II. IR upon II will be how much? 0.64. IR upon II. This ratio is 0.64. Got it? Now transfer this. So AR square will be 0.64 into AI square. AR square will be 0.64 into AI square. And now just take square root on both the sides. Square root of this will be AR. Square root of 0.64 is 0.8. square root of this is AI. But what do you mean by AI? It is amplitude of incident wave, and amplitude of incident wave they have given as only capital A, that's all. So instead of AI you may write A, correct? So amplitude of reflected wave is 0.8 times amplitude of incident wave. Fine. The equation representing incident wave they have given as yi equals to A cos AX plus BT. Yi equals to A cos AX plus BT. That is what they have given. This is the amplitude of incident wave which they have given as capital A. So instead of AI I am just writing capital A. Fine. But if this is the equation of incident wave, what should be the equation of reflected wave? Don't you know? I told you last time, you must make change of sign at two places, one inside and one outside. Inside change of sign is due to reversal of direction of propagation of wave, and outside change of sign is due to reversal of reversal of shape of the wave. I repeat, inside change of sign is due to reversal of direction of propagation of wave, and outside change of sign is due to reversal of shape of wave. This plus sign indicates that incident wave is being incident in the form of crest, but don't you know, while getting reflected it will be transformed into trough. If it is incident, while being incident, if it is crest, then while being reflected it will be trough. That's why instead of plus I am writing here minus, correct? Come on, wave is made incident in the form of crest, then while getting reflected it is getting reflected in the form of trough. Wait, now you must write here amplitude of reflected wave. Right now it is different than amplitude of incident wave because the intensity of reflected wave is different than intensity of incident wave. That's why naturally when intensity will change, amplitude also will change. So write here AR, that is amplitude of reflected wave, correct? Then cos as it is, come on, BT as it is, but instead of x we are supposed to write minus x. When instead of x, when you write minus x, it will be now minus AX, correct? Come on, inside change of sign is due to reversal of direction of propagation of wave, outside change of sign is due to reversal of shape of wave, correct? Fine. Now this minus sign as it is, what about AR? AR is right now 0.8A. AR is how much? 0.8A. AR is 0.8A. And cos of, come on, BT minus AX, BT minus AX, fine. So now this is the equation which represents, come on, reflected wave. That is what they have asked, okay? And now what about resultant wave? Resultant wave, according to principle of superposition, mathematically you can write y equals to yi plus yr. Y equals to yi plus yr. Yi plus yr means what? This plus this. Correct? Now please take care. Each and every step I am going to explain you nicely. You please concentrate on the screen now. This plus this, meaning thereby this plus this. Come on, this plus this, this plus this. So I am writing here A cos BT plus AX, A cos BT plus AX minus 0.8A cos of BT minus AX, cos of BT minus AX, correct? Simply I have make addition on right hand side, that's all. And now this A you can split like 0.8A plus 0.2A. 0.8A plus 0.2A will make A, correct? So instead of A I just split it, 0.8A into cos of BT plus AX as it is, plus 0.2A cos of BT plus AX as it is. I repeat, 0.2A plus 0.8A will make A. Simple? Fine. And this term I have written as it is, no change whatsoever, minus 0.8A cos of BT minus AX. Got it? Wait. And now from these two terms we can take 0.8A common. That's why we had split it like that, so that we can take 0.8A common. That's why we split it like that, okay? Fine. 0.8A if you take common, left inside the bracket, from here it is cos of BT plus AX minus left inside the bracket from here it will be cos of bt minus ax, cos of bt minus ax. Take care regarding plus and minus sign, please. And now, this term as it is, 0.2a cos of bt plus ax, 0.2a cos of bt plus ax, fine. And now, this 0.8a I am writing as it is, wait, this cos of bt plus ax minus cos of bt minus ax, in place of that, what I am going to write, I am showing you. There is a formula in trigonometry, cos of a minus b minus cos of a plus b. Cos of a minus b minus cos of a plus b, that formula is 2 sin a sin b. So, I want to use this. That is why let me convert the inside part like this. Wait, what I am doing now, minus sign I am taking out. If I take this minus sign out, if I take this minus sign out, then outside part will become minus, and then when you take this minus sign out, this minus term will become plus, and this term which is plus will become minus. So, in short, order will get reversed, fine. So, minus sign I am taking out, okay. This term as it is, this term as it is, no change whatsoever, 0.2a cos of bt plus ax, fine. And now tell me, minus 0.8a as it is, minus 0.8a as it is. But now tell me, take this as capital A, take this as capital B, take this as capital A, take this as capital B. So, it is something like cos of a minus b minus cos of a plus b, cos of a minus b minus cos of a plus b, and that formula is 2 sin a sin b, 2 sin a sin b. So, instead of this bracket I can write 2 sin a sin b. Look, 2 sin a, capital A means here bt, into sin b, capital B means ax. So, 2 sin a means capital A means bt into sin of capital B which is ax. I repeat, cos of a minus b minus cos of a plus b should be equal to 2 sin a sin b. Take this as capital A, take this as capital B. So, now it is cos of a minus b minus cos of a plus b. It is 2 sin a sin b, 2 sin a sin b, correct. This outside part minus 0.8a as it is, look here as it is, and plus this additional term is always there without any change. You must write 0.2a cos of bt plus ax, 0.2a cos of bt plus ax, fine. And now minus as it is, 0.8 into 2 will make 1.6 into a into sin of ax I am writing first, into sin of bt I am writing later. And now this equation, I mean this term as it is, 0.2a cos of bt plus ax. Now tell me, this is the equation which is similar to equation of stationary wave, S for stationary, S for stationary. So I am writing here ys. This term represents equation of stationary wave, let it be ys, and this term represents equation which is of progressive wave. P for progressive wave, S for stationary wave. So, instead of this term I am just writing ys, instead of this term I am writing yp. Come on, what is the equation of stationary wave? It is ys equals to minus 1.6a into sin of ax into sin of bt. And what about equation of progressive wave? It is yp equals to this much, 0.2a cos of bt plus ax. We were asked to find out the two component equations, one which represents stationary wave, it is this, and another which represents progressive wave is this, okay. Don't you know the equation, I mean the format of equation which represents progressive or travelling wave, what was that? Y equals to a sin or cos into bracket, come on, omega t plus or minus kx. So, this equation is similar type, that is why this equation represents progressive wave and this equation is representing stationary wave, correct? Fine. Now, here I have shown two very good small results which you don't have to prove in the examination, but to understand example number 15 after this, you will require to use those two results. In textbook, they have not proved those two results. They have taken just, they have made the use directly. You will not understand, you will have problems in understanding. Better you concentrate here, correct? This proofs which I am going to show you is not given anywhere, okay? Try to understand. Specific density of block. Specific density of block. Remember how did we define specific density of block? That is density of block divided by density of water. Simple. Density of block divided by density of water. Density of block, but block is solid substance, so I am writing S, S for solid. Density of solid substance divided by density of water, W I am writing for water. Simple, fine. So this ratio will give you specific density of block. Now density of block is nothing but mass of block divided by volume of the block. Simple. This density of water is nothing but mass of water divided by volume of water. Why I am taking these two volumes equal? Naturally, when you immerse given block completely into water, it will exactly displace only that much volume which is the volume of itself. Okay? When you immerse block completely into water, it will displace volume of water equal to its own volume. So this is the volume of block and this is the volume of water displaced by immersed part of the block, and it is also equal to volume of the block. So these two volumes right now they are equal. So V and V getting cancelled. You know what is MW? It is mass of that water which is displaced by immersed part of the block into water. Correct? You mind well, you are going to immerse this block completely inside the water, and then whatever water is displaced, that water has mass MW. Got it? Fine. Because these two volumes are equal, we will be getting cancelled, giving you MS upon MW. MS upon MW. Now just multiply by G, numerator and denominator. So here I am writing MS into G, denominator I am writing MW into G. But don't you know, mass into gravitational acceleration will give you weight, and weight of the block in air I am taking as W1. Weight of the block in air I am taking as W1, and this MW into G will give you buoyant force exerted by water when you immerse the block into the water, and that buoyant force will also give you apparent decrease in weight of the block when you immerse it in the water, and that apparent decrease in the weight is W1 minus W2. W1 minus W2. How I am showing you? Weight. What is W1? Weight of the block in air. Okay. But when you immerse it inside the water, what does water do? It exerts, come on, vertically upward force which is called buoyant force. And how much is buoyant force? According to Archimedes principle, it should be equal to MW into G, where MW is mass of water displaced by immersed part of the block. Okay, fine. And that much force will get decreased from the downward weight because it is opposite. Then what is the weight of the block in water? It will be W1 minus MWG. W1 minus MWG. Come on, W1 minus MWG. Correct? This much will be the weight of block inside the water. Let it be W2. Okay? And now find out MWG from here. It will be W1 minus W2. MWG is how much? W1 minus W2. MWG is how much? W1 minus W2. Correct? What was W1? Weight of given block in air. What is W2? Weight of the same block in water. Then what will give you? This W1 minus W2 will give you apparent decrease in the weight of the block inside the water. Okay, fine. Now in textbook, they have taken this result, granted, I have proved it here. Okay, look, this specific density of block, you can just write this way, W1 upon W1 minus W2. That is weight of the block in air divided by apparent decrease in the weight of the block in water. Correct? Fine. Now more difficult than this is this step. Try to understand. This proof is nowhere, is given nowhere. Huh? Specific density of liquid, how would you find out? Specific density of liquid, by definition, it is nothing but density of liquid divided by density of water. Density of given substance divided by density of water. Right now, given substance is another liquid other than water. Okay. So, I am writing rho L, L for liquid divided by rho W, that is W for water. Ratio of density of liquid to the density of water will give you specific density of that liquid. Wait. 10, transfer this rho L in the denominator's denominator. Then you can write 1 upon rho W upon rho L. 1 upon rho W upon rho L. Wait. Just multiply numerator and denominator by rho S. That is density of solid substance, rho S. Multiply here also. And now you can rewrite this way. Rho S upon rho W. Rho S upon rho W. Correct? Divided by rho S upon rho L. Rho S upon rho L. Rho S upon rho L. Correct? Fine. So, rho S upon rho W divided by rho S upon rho L. Rho S upon rho W divided by rho S upon rho L. Fine. Now, what is rho S upon rho W? Rho S upon rho W is W1 upon W1 minus W2. W1 upon W1 minus W2. Correct? Now, tell me what will be rho S upon rho L accordingly? Try to concentrate here now. What is this rho W? Density of water. Correct? So, whichever liquid you are taking into consideration, its density appears here. Correct? Now, the apparent decrease in the weight of the block appears here. Correct? That liquid, here it is water. So, here I should write apparent decrease in the weight of the block in water, and it was W1 minus W2. Correct? Fine. Now, similarly, what does it appear here? Density of liquid. Then, here what you should write in the denominator? Apparent decrease in the weight of the block in that liquid. And if inside that liquid the weight of the block is W3, then what is apparent decrease in the weight? It is W1 minus W3. Once again, the weight of block in air is W1. Weight of the same block in a given liquid other than water is W3. Then when you immerse that block completely inside that liquid, what is apparent decrease in the weight? It is W1 minus W3. W1 minus W3. So, the way you have written in place of rho S upon rho W, the way you have written this much, W1 upon W1 minus W2. Similarly, here rho S upon rho L, you can write this way, W1 upon W1 minus W3. That is weight of the block in air divided by the apparent decrease in the weight of the block in the given liquid. It is W1 minus W3. Correct? And now tell me, W1 will cancel. And now, don't you know, denominator will become numerator. So, this will be transferred in the numerator. So, now it is W1 minus W3 upon W1 minus W2. Now, in textbook, they have skipped all these steps. They have not explained at all, and directly they have written this formula. I hope you will appreciate the way I explain. Remembered? I mean, you can understand? Simple? Fine. Now, please remember this formula, W1 minus W3 upon W1 minus W2. In textbook, they have not given all these steps. So, in examination also, you must not write all these intermediate steps. Okay? You can write this formula directly. Now, these two results we are going to use in the next example. Now, kindly read the statement of example number 15. Read it? Look. They are talking about sonometer. In the construction of sonometer, we have one metallic wire which is at one end tied with a fixed rigid support, and from the another end we just suspend some weight, and that wire is passed over some frictionless pulley. Okay, fine. This figure you are not supposed to draw in the examination because they are not given in the textbook. Now, using this sonometer, we can determine the wave velocity which is propagating in this wire. I am showing you how to find out. Look, when you suspend this block, you know weight is nothing but gravitational force which is always vertically downwards, let it be W, correct? And because of the weight suspended, this wire remains stretched. So, there is some tension developed in the wire, let it be capital T, fine. Here also tensions you can show equal in magnitude, come on, pointing towards each other, correct? Now tell me, this tension will balance this tension, but what about this tension? This tension will balance this weight. So, I mean to say T is equal to W, because W is right now external force, T is right now restoring force, they have to be equal under equilibrium. So, T must be equal to W, T must be equal to W, weight. Now, in this wire, when you produce these stationary waves, at that time what is the fundamental frequency? Expression of fundamental frequency last time we had obtained, remembered? It was V upon 2L, V upon 2L, same formula I am writing here, V upon 2L, and instead of F1 I am just writing F, but though I am writing F, you must understand it is fundamental frequency, it is minimum frequency, okay, wait. Now 1 upon 2L as it is. What about wave velocity? Wave velocity of transverse wave in this wire, remembered? What was that? V equals to under root of T upon mu. V equals to under root of T upon mu. Remembered? What was capital T? Tension in the wire or tension in the string. And what is this mu? Mu is linear density of mass. Linear density of mass means mass per unit length. Remembered? Fine. So, this wave velocity I am writing under root of T by mu. For a given wire, this length L is constant. For a given wire, its linear density of mass mu is also constant. When these two are constants, what is the relation between F and T? Come on, relation is F proportional to under root of T. F proportional to under root of T. What is F? Fundamental frequency. Don't say only frequency, say fundamental frequency which is minimum frequency. What about capital T? It is tension developed in the wire. Now tell me, when you take square on both the sides, then F square is proportional to T. F square is proportional to T. Don't you know from mathematics? If A is proportional to B, you can write reverse also, B proportional to A. Similarly, if F square is proportional to T, you can write the reverse, that is T proportional to F square, correct? Remove sign of proportionality, put some proportionality constant small k. T equals to K into F square. But instead of capital T, we can write capital W. You know this tension is going to balance this weight. So, instead of T, I am putting W over here, T equals to W. In short, the formula of weight is how much? W equals to K into F square. Now, tell me, if you suspend this block in air, then weight is different. If you just immerse that block in water, then weight is different. If you immerse that block in a given liquid other than water, then weight is different. I mean to say, as the weight will change, depending upon that, the fundamental frequency will also change. Fine. In air, let it be W1 equals to K into F1 square. From this relation, instead of W, I am putting W1. Instead of F, I am putting F1. Come on, in water, it is W2 equals to K F2 square. And in a given liquid other than water, W3 equals to K into F3 square. Mind well, take care, don't be misguided. Though I am writing here F2, it is not second harmonic. Though I am writing here F3, it is not third harmonic. This F2 means still fundamental frequency producing the stationary waves in this wire in case when you are immersing the block in water. This F3 is still fundamental frequency of the stationary wave produced in that wire when you immerse block in a given liquid. Got it? So, the way you are just changing the surrounding medium surrounding to the block, depending upon that this weight will change, depending upon that this fundamental frequency will change. That is why. What is specific density of block? Specific density of block. Specific density of block. Specific density of block is how much? It is W1 upon W1 minus W2. W1 upon W1 minus W2. Can you speak out that formula in words? What is W1? Weight of block in air. What is W1 minus W2? Apparent decrease in weight of the block in water. Fine. W1 is K into F1 square. Correct? K into F1 square. W1 is K into F1 square. W2 is K into F2 square. Can you take this K common? Yes. Will be getting cancelled with this K. Ultimately, you will get F1 square upon F1 square minus F2 square. So, when you have found out these fundamental frequencies, you can put the values here, you can simplify, then you can determine the specific density of block. Got it? What about specific density of given liquid? Specific density of given liquid is this much. Come on, W1 minus W3 upon W1 minus W2. Come on, W1 minus W3 upon W1 minus W2. What is W1? It is K into F1 square. W3 is K into F3 square. W1 is K into F1 square minus W2 is K into F2 square. This K common, this K also common, getting cancelled from numerator and denominator, giving you finally F1 square minus F3 square upon F1 square minus F2 square. When you know all these fundamental frequencies, you can put the values here, simplify, you will get the specific density of liquid. Okay, how to get this formula, that's what I have explained you here. But this whole explanation, all these steps, you are not supposed to remember, you are not supposed to represent in the examination. Directly as per textbook, you can write specific density of liquid is this much. Now in words, how would you speak out? This is apparent decrease in the weight of the block in given liquid divided by apparent decrease in the weight of that block in water. Got it? And such a ratio will give you specific density of liquid. Got it?